Okay, so this is 5.6, just more of an FYI for y'all. But so the only notes for this are really what's written at the top here. So the guidelines for solving related rates. Identify all given quantities and quantities to be determined. So basically knowns and unknowns. Make a sketch and label the quantities. So most of the time we're going to draw a picture. Not every time, but sometimes in the book they'll give you a picture. Sometimes you have to draw one. Write an equation involving the variables whose rates of change are either given or to be determined. So this is kind of like pick an equation that meets the requirement. So it might be a volume equation, it might be area, might be like a triangle like Pythagorean theorem. And then use the chain rule to implicitly differentiate. And you won't always have to necessarily use the chain rule, but a lot of times it does end up happening. But to implicitly differentiate both sides of the equation with respect to t, so with related rates, everything is with respect to time, like miles per hour, feet per second, things like that. After completing step 3, substitute into the resulting equation all known values for the variables and their rates of change and solve the required rate of change. So whatever is like missing, basically. So start with example 1. A police cruiser approaching the right-angled intersection from the north is chasing a speed car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at that instant of measurement, what is the speed of the car? Okay, so this problem would have given you, where is it? A picture that looks something like that, where they've show the car going one way and the cruiser and all of that. Okay, so I'm going to just basically draw that for you. Like, let's assume you weren't given a picture. How would we do this? So, I'm going to draw a triangle. So this is my intersection. The car is here, cruiser is here. So this is going to be going this way and going this way just for reference. So I'm going to call this side X, this side Y, and the hypotenuse value Z. Now the letters you pick doesn't really matter, but I was kind of saying yesterday, like, we don't usually use like A, B, and C because they're usually thought of as constants. We usually try to use like X, Y, and Z or W, X, Y, Z or something like that because we want letters that are typically thought of as variables. So we're going to set it up with things that we know and things that we don't know. So I'm going to do X, Y, Z. And then I'm also going to have dx dt, dy dt, and dz dt. Back it up here a little bit. It got like way smaller when I did that. So you can see. Okay, so let's see. We've got the cruiser is 6 miles north of the intersection. Okay, notice he's north of the intersection. It's not that he is traveling north. Okay, he's north of the intersection. And so he is traveling, we'll get to that in a second. And then the car is 0.8 miles to the east. So X is the car. So that is 0.8 miles. And we want units on things. The cruiser is 0.6 north, so this is 0.6 miles. Z is going to be unknown. So let's do this. Highlighting things that we have. All right. The distance between them and the car, okay, so that's that Z value is increasing at 20 miles per hour. So that's going to be dz dt. Whoa, not that. None of that.
What's dz dt?
20 miles per hour.
Because it's in relation to...
That's the distance of which the, the distance between them. So that's this value here. So as the cruiser is getting closer to the intersection, the car is getting farther away, basically. If the cruiser is moving at 60 miles per hour, so that is the y dy dt. Distance and a measurement, what is the speed of the car? Now, that value, he's traveling this way, so that's going to be a negative value.
Wait, who's traveling?
He's traveling south. Yeah. Like he's so many miles north of the intersection, but he's traveling south.
Okay, so the 60 miles per hour. Okay.
Yeah, so that's going to be negative in this case. So then, what equation do we know that associates these things?
Similar triangle.
Pythagorean theorem.
Which correlates the Pythagorean
The Pythagorean.
X squared plus y squared equals z squared. I forgot to highlight this.
I know, me too.
All right, so we've done step 1. We've done step 2. So now we're on to step 3. We need to take the derivative. Okay, everything is with respect to t, so it's implicit on everything. So the derivative is going to be 2x dx dt plus 2y dy dt is equal to 2z dz dt. So, we are trying to solve for dx dt. Okay, that's what we're trying to find. What is the speed of the car? So, I want to get dx dt by itself. So, what do I need to do?
Subtract all 2y, dy, dz.
So then,
Now I would, so you're trying to get what by itself again?
dx dt.
So divide by 2x.
So, dx dt is equal to 2z. Oh, that sounds awful. dz dt minus 2y dy dt divided by 2x. Now, we didn't have Z. Z wasn't given to us, but can we find Z?
We sure
Yeah.
Yeah, we can.
We can.
Like,
Using the Pythagoreans. As
Using Pythagorean.
So we can find Z by doing the square root of 0.8 squared plus 0.6 squared.
That's why we're doing it.
that's what she's the teacher.
So sometimes it gives you everything, sometimes you have to find a piece, sometimes you have to do multiple things to find multiple pieces. It just depends. How do you get an error? By
Arrow.
typing in something wrong.
It's like
Oh.
17 arrows.
Yeah.
Just
Oh, I heard error. I didn't hear.
Why
The
wasn't
store
that-
button?
Oh yeah, that's what it was. For some
Oh.
reason, I think my calculator was on. Okay, never mind.
One.
I got one.
Wow.
Let me see what I got.
Isn't that so fun?
You know why? Because 8 squared is 64 and 6 squared is 36, and those add together give you 100.
Yes. That is what I deciphered.
All right, so now we're going to be plugging things in, but what do you notice about this equation?
It's
It's a
I don't know, to be honest.
Can I take anything out to reduce?
Two.
Okay, there's a 2 in every piece. Remember, you can't just cancel here. We've got to cancel them all the way across. So 2's gone. Just to make life easier. So then I plug stuff in. So I'm running out of space. So I'm just going to do this. So Z is 1 times dz dt is 20 minus y is 0.6, oh dear, times dy dt is negative 60 divided by x is 0.8.
Wait, yeah.
We'll stop talking about your bipolar kicking in.
What'd you just? His bipolar kicking in?
That is what he said.
Oh my gosh! Didn't you just? We just gave a
Did I-
whole
wait, did I say
presentation
that?
on that.
It's my acute short-term memory.
Did you talk about hypochondriac syndrome too?
For bipolar disorder.
No, but
Because Nathan is saying he has it.
We didn't talk about
That's why I was saying, this is he a hypochondriac?
That makes sense.
that. He probably is.
I don't remember that in the presentation.
You know what that means?
Say it again.
Hypochondriac?
Do you know what that means?
What does that mean?
It means
It
you
means-
always think you're sick and you always think
You
like
when you
have
listen
something.
to
Like somebody,
descriptions of stuff or like sicknesses,
You start feeling
you
the
start
symptoms.
feeling
You-
the symptoms.
like you think you have it.
So like, if I started describing
Kind of like the
symptoms of
placebo
lice
effect in the
to you,
opposite direction.
If I started describing the symptoms of lice, like itchy head, and
You're
stuff,
gonna start
you're
scratching
gonna
your
start
head.
Scratching your head because you think you have the symptoms.
Because your head just gets so itchy. He's like, oh
And it's
no.
not like something you can just not do. It's just a conscious thing that people have that.
And some people are like really bad, like really, really bad hypochondriacs. Like they think they have everything on the planet. That's why people can't Google like WebMD.
What's WebMD?
Oh my gosh.
What is WebMD?
Okay. Do we have an answer for this? 70.
I also got 70.
So 70 miles per hour. So what I like to do is typically in another color write what I was actually trying to find. Whee! So that way it's very evident what you were trying to solve for, but I usually just put it all in there. Kind of like when we, you know, ironically enough, solved triangles last year. Kind of the same thing. Like how I had you write like all the angles and all the sides, even if you didn't need to solve all of them, I'm like write them all out.
I like
Do you
that
have a
section,
colored pen
but
that's like not red?
I have
I have
several.
a surplus. Do you want a pen or a little marker, like those little Papermate marker things?
Wait, let me give him.
Paper.
I feel like
Oh, you want marker?
What
The
color do you
setup-
want?
Yes.
like the
Purple?
difficulty in these problems are gonna is
Brand
gonna be
new.
setting it
Oh
up
my
correctly.
goodness, I feel so special.
Look at you go.
Because like if you set it up correctly, you can plug in.
Right. It's usually the setup. Honestly, the hardest part of these is setting them up. It's not the derivative. It's not the finding the answer. It's the setup. Because if you
Yeah.
don't know a formula, you're not gonna get it right.
Right, like it's easy. It's pretty easy.
And sometimes what we're gonna see in the next problem is there's gonna be things that we may know the information of, or maybe like we could have, like, say we didn't need to use Pythagorean theorem, but we did because we wanted to go ahead and find z. But let's just say we weren't gonna need z in the end, hypothetically.
Yeah.
Okay, sometimes we may have found something and we don't actually need it. It's just kind of like extra information, you know, that like you would throw out because I don't need it.
We like good for you.
Yeah.
Well, it's like the exact
All right, so this one, we have a pebble is dropped into a calm pond. Okay, not like skipped, it's just like dropped, okay, into the water. Has anyone ever done that before? You know what happens?
Wait, what? A pebble's dropped?
Oh my gosh.
It goes. Or something
what?
like
A
that.
pebble, not a rock.
Same thing.
You ever dropped like a little
Not as
tiny pebble like into the water?
Yeah.
You see what happens? Okay, it just
Yeah.
okay, it
Not as
goes
big
out
of a
right in
reaction.
concentric circles.
I learned how to
What
skip
does
a lot.
concentric mean?
I know.
One
We,
in sync.
I think like
Like circles
They-
that just keep
yeah.
going. Like they're even, like evenly spaced basically.
Yeah, ripples, right?
Yeah.
we learned how to skip rocks at TLC.
Well, that's exciting.
Yo.
All right. Causing ripples in the shape of concentric circles. The radius of the outer ripple is increasing at a constant rate of 2 feet per second. When the radius is 4 feet, find the rate at which the area of the disturbed water is changing. Okay, so we've got, I'm going to draw this. So we have a rock being dropped into the water, okay, or a little pebble,
That's what that dog is.
and there's the concentric circles going out around it, okay, to help you visualize it. Okay, they're
Why
not
doesn't
perfect,
my
but
paper correct myself?
I know.
you should see the one that's drawn on my paper. It's not pretty.
Show us.
I can't give you the answer, but
That's better than mine. Mine's a Google. It looks like one of those Townsend crackers.
townhouse?
Townsend?
Who's
Yes.
Not like Sophia and Dylan.
Yeah, no.
Okay.
Like those oval townhouse crackers.
All right, so things that we know. Okay, given quantities. The outer ripple is increasing at a constant rate of 2 feet per second.
Okay.
When the radius is 4 feet, find the rate at which the area of the disturbed water is changing.
Should make them do it themselves.
All right, so what things do we know? What quantities, like letter-wise, what do we know? Radius?
And
Or what can we find with the information we have?
DT, DR is.
We
DRDT.
can find a
DRDT is 2.
what?
Okay, DRDT is 2 feet per
Oh.
second.
I didn't.
Okay, that's the rate that the radius is changing at.
I didn't compute what that was.
real, like,
Okay, the radius is 4 feet. Okay, what else am I going to need to find?
you're gonna need to find
The circumference
area.
of the concentric.
Area, but the rate at which it's changing, so what might that be?
DATT.
DADT. Okay, so area, even though it's not listed, that might be something I need, maybe not. Okay, how would I find the area of a circle?
Wait.
Pi r.
No,
Pi r squared.
Area is pi r squared.
I said it right this time.
So that means it would be pi times the radius is 4, so 4 squared. So the area would be 16 pi. Okay. No, maybe we don't need it. Maybe we do. So I'm going to start with that area of the circle formula because I'm trying to find the rate at which it's changing. So A equals pi r squared. So what do I do next?
Derive.
Derivative.
Which would be what?
2 pi r.
The part of it.
Wow. What
Plus
is that? Oh,
dt.
dr dt.
Yeah. I can't remember, like,
What about this side?
my brain is not working.
You do something with that side?
You have to take the derivative of both sides.
Oh, right.
So
dA
dA/dt.
dA dt.
I like how that was like a statement, but also like a question.
Y'all were like not sure about it.
Not convinced.
All right, so now when I go to plug things in, okay, I'm finding dA dt. Fortunately, that's already by itself. Is there area left? Like, is just an A left that I'm going to be plugging an area to?
No.
No. So this really wasn't necessary, but we don't always know that right away. So it's good to just go ahead and find those things right
Why is it
away.
not necessary? I did not compute it. Just-
There's no A left in the equation to plug it into. So we just don't need it. Not a bad thing to have, but we didn't end up needing it, so we just crossed it out.
So we're just plugging it.
Or you can just leave it and just disregard it. It doesn't matter.
So we're just plugging it now.
Yep. So dA dt is equal to 2 pi times 4 times 2. And you could leave it in terms of pi to get 16 pi. Or you could multiply the pi through it. It really doesn't matter. So dA dt is going to be 16 pi feet squared per second. Okay, because it's the rate that it's happening at. So 16 pi feet squared per second. Wee.
That's
So is that the answer?
Yes.
Oh, it is. That wasn't too crazy.
This is easier than I
Well, we're
thought.
also still in the
We're on
second
number
round.
2.
I know. I was
Don't
about
get
to
excited.
say.
Don't get crazy.
Don't get crazy.
I mean, I used
Yeah,
to
that's
restroom
what
if
I'm
I go
telling
really
you.
fast.
That's up to you. Go for it.
Actually, I don't want
I
to.
mean, you don't have to, like,
Just go. Well, don't think about it. Just go now.
Okay, we're going to
Not going.
skip number 3 for right now. Okay? We're going to come back to it. Okay, because number 3 is a little more difficult. But we'll go ahead and do number 4.
We're not as important.
No, there's just a nice order to doing these problems, and the teacher that I got these from said wait until the second day to do that one.
oh.
So I'm gonna take his advice because he taught AP a lot longer than I do. Whatever. So I'm gonna take his advice and save that one for tomorrow.
Right.
Okay.
And move on to other things that are more similar to what we've been doing that are a lot easier. The cone problem or conical tank is like one of the most common problems you'll see, but also one of the harder ones because it's not something you're used to.
Is that
Like a cone?
Yes, like a funnel, but not like, but it's like this.
Conical?
Basically, it's going to involve
Conical?
similar triangles because of that, and that's why I don't want to do it yet because that's stuff you're not familiar with probably.
No, I'm
So
not.
okay, so we're gonna jump to number 4. All right, a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Really hope somebody's not on it.
I know, that's crazy.
How fast is the top of the ladder moving down the wall when the base is 7 feet? So, I've got a wall.
That's a beautiful.
Thanks, I tried. I've got the ground. Guess what's coming next?
Oh,
The ladder.
A ladder.
Oh, triangle.
Isn't it crazy?
It's so crazy.
And a ladder.
Go back and watch this video.
So, what's the?
Hopefully it saves.
Uh-huh.
I really hope this video saves. I'll actually be so down about it. It's not. So.
I'm all the way updated on every video that I have up to yesterday afternoon is uploaded.
Yay.
Praise the Lord.
All right, so ladder, this side I'm going to call L for ladder instead of Z like I used before. It doesn't matter, but I'm still going to use X and Y just for directional sense for the other stuff. But if you were like, I really want to use G and W, then be my guest. I don't care. But I'm going to use X, Y, and L.
What if we use L-O?
S, T, and J.
Those are some weird letters, but sure.
It's random.
I mean, S and T are my name, but like
It's random.
weird letters for math.
I'm not
All right.
gonna do that.
So I'm going to start with things that I know right away. Okay. So I'm going to highlight first. All right. So the ladder is 25 feet long. It's leaning against the wall of the house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Then in part A, it says, how fast is the top ladder moving down the wall when its base is 7 feet basically away? So those are all things that I know. So I'm going to set up my... Stop that. X is the base, so 7 feet. Dx dt, do I know that? Yes. Moving away from the wall at 2 feet per second. I need to slide some of this over. Y, we don't know, but we'll be able to find it, right? Because we have the length of the ladder. So we have Z, or L, confusing myself. L is 25 feet. So why did I, hold on. I wrote dx up here. It's dx dt, just FYI.
Oh,
Could have had a cookie point.
I wrote DXDT on that paper.
Good for you. I wrote dx dt, or I said dx dt and wrote dx dx. And then dy dt. All right, so right now I've got a lot of things I don't know, right?
Yes.
Yeah, too many. For all I think.
Can we find Y?
Story of my life.
Yes, let's find y first.
Yay.
So this was 7, this is 25. So just for reference. So y is equal to the square root of 25 squared minus 7 squared.
I don't know that off the top of my head. Wait,
Square root.
I know.
Oh, then we have, I don't know. I can't do
24.
24.
That makes sense.
Yay.
Yo, we graduated.
All right, so 24 feet. It's crazy. All right, now
Oh.
I have 2 unknown values still, correct?
Yeah.
Yeah.
Sadly.
But do we actually need them?
That's the question. I'm going to ask this question. Don't be smart with me.
Oh.
Can the length of the ladder change?
No.
No. Good answer.
What were you? What
I was
were you-
waiting for someone to say, well, there's adjustable ladders that you can change the
I
height.
thought it.
We all thought it, but you
Got
know.
it, like,
Okay. Height doesn't change. Height of ladder doesn't change.
oh, so you just crossed that out?
Yeah, I basically just put a slash through it. Because I don't need it.
I don't think that's what we were looking for.
Yeah, what exactly are you?
We're looking for how fast the ladder is moving down the wall. So dy dt is what we're trying to
Oh.
find.
I just assumed it said ladder, so I was like, oh, we must be looking for a ladder.
I thought I already read that. I'm just kidding.
All right, so
Whatever.
we know that x squared plus y squared is equal to L squared. But we just said that the height of the ladder isn't changing. That means it's constant. So I'm going to replace L with 25.
Okay.
So x squared plus y squared equals 25 squared. Now we take the derivative.
Okay.
Okay, so this is why it was important that we notice that it didn't change. So now, taking the derivative, what do I get?
You get 2x dx dt.
Dx dt
Yes.
plus,
2y dy dt.
okay, equals
625. I mean, never mind.
0.
0. Now I'm trying to get dy dt by itself. Just for the sake of space, I'm going to move everything at once. I'm moving the 2x dx dt to the right, making it negative, and dividing by 2y. So the 2's are going to cancel. But I'll write those and just let them disappear. Negative 2x dx dt over 2y, and then the y's are going to cancel.
You mean the 2?
2's. Yes. I marked out the right thing.
You did.
See, I said the wrong thing this time, but I wrote the right thing.
Happens to the best of us.
All right, so dy dt is equal to negative x is 7. Dx dt is 2 over 24.
What?
Wait a minute.
We shouldn't even need a calculator for this until the very end.
Oh.
Wait, can you zoom in on that? What does that say? Negative 7?
So you want
Negative 7 times 2 divided by 24.
So you want a fraction then?
Yeah. A lot of times
Well,
we leave these.
'cause I was
A
gonna
lot of
say-
times we leave these as fractions, but yeah,
Oh.
I mean, if you want to do the decimal, that's fine.
Okay.
But
Well,
I
that's why I was getting.
I usually just leave them as fractions.
Okay, so then 14 over 24, which reduces to
Negative.
Huh?
Negative.
Negative 14 over 24, which reduces to negative 7 over 12.
7 over 12. Negative 7 over 12. And we were in feet.
Christian?
All right, so dy dt is equal to negative 7 over 12 feet per second. I forgot the per second over here. There we go. And I will say some problems, they don't give you like X, Y, and L. They might actually give you all the rate of change values, and we're finding the other thing. It just depends on what the problem is. All right, so the continuation of this problem, I don't know if we'll be able to finish it, but consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. So everything is the same except for, do we need the length of the ladder for area of a triangle? No, because what's the formula for area of a triangle?
The base times the height. BH divided by 2.
Okay. 1/2 in terms of the letters that we're using, x and y. Oh, I forgot to put y back. 1/2 xy. So we still have x is 7 feet. Y is still 24 feet. Area is what we're trying, or we'll find area. Because we can, right?
Oh, yeah.
Of course, you can do
Whoa, I don't know about that.
So we're looking for the rate that the area is changing at, meaning that our other values stayed the same. So these are still 2 feet per second. Negative 7 over 12 feet per second. So the area would be 1/2 times 7 times 24. What is that, 84?
Yeah.
So 84 feet squared. Well, 7 times 12, I think, is 84. So. All right, so now I need the derivative, but what is this?
A chain
It's
rule,
a
product rule.
Product
Yeah.
rule. So dA dt is equal to what?
Oh, okay, so 1/2.
If you want to just do the 1/2 out front and not have to worry about it, we can just multiply it through at the
Oh.
end.
Okay.
If I mean, you can do it either way, but
Okay, so let's do that. The 1/2, and then okay, so y, no, x,
No, 1.
1.
Wait, product.
but we're taking the derivative with respect to t, so it's not 1. It's
dx
what?
dt.
It's dx dt.
Ah,
Let's finish the derivative and then we'll plug it in tomorrow and finish it.
okay.
Okay, and then
Times
Times
y
y
times y
plus
plus x.
x dy dt. Such a
okay, and then we'll basically just plug in numbers to find dAdt, but we'll finish that up tomorrow when we start.
Maybe so, sure.
Yes.